In my last class, I discussed about the acceleration. Acceleration is the rate of the change of the velocity. When the velocity changes, okay, then acceleration is produced. Now, today I will teach you a graphical representation of motion. First is distance time graph. Okay, distance time graph, an object moving with uniform speed. How does it look like? Okay, time is independent of anything, but distance depends on time. Therefore, we draw time on the x-axis and distance on the y-axis. So, a body moving with uniform motion will have a straight line graph. Okay, straight line graph. How does it look like? Just I am showing you. See, this is a body moving with uniform acceleration. The graph is a straight line. This is a graph, it is a straight line, The time axis is x-axis and the distance is y-axis here. So it is a straight line graph. These straight line graphs indicates that the body is moving with uniform speed. What is uniform speed? When the body covers equal distances in equal interval of time, then that is uniform speed. Okay, when it is cover unequal distances in equal interval of time, then that is known as non-uniform speed. So we can use this distance time graph to determine the speed of an object. Speed, if you divide the distance by time, we'll get the speed. Right? Look at this is a graph of non-uniform. Okay, speed it is. Look at the graph is a curved one. It's not a straight line. Okay, therefore this graph is of non-uniform motion. Right? This is velocity time graph. Look at the graph is a straight one, it is here now, and this is uniform motion of the velocity time graph for a uniform motion of a car. Okay, the velocity time graph gives displacement of an object moving with uniform velocity. So, okay, the x-axis is having the time and y-axis is having velocity. It is here. Can you see the velocity of the body is 40 km per hour. It is not changing. Okay, in each and every hour the velocity is 40 km per hour. That means the body is moving with uniform velocity. Now the displacement is the area, is a shaded area enclosed by the velocity time graph and the time axis. Okay, and this is the displacement, how much the body is displaced. Okay, this shaded area shows the displacement of a body. Okay, the area of the shaded region can measure the displacement of a body. Now this is a velocity time graph for a body moving with uniform acceleration. Okay, uniform acceleration. Okay, here the acceleration of the body is changing uniformly. Right? So this is also a straight line. When the body moves with uniform acceleration, then the graph is a straight line. and the body uh, is the body is changing its velocity uh, at in equal interval of time and covers the same distance in each and every hour it is. So this is it. Velocity time graph for moving with a uniform acceleration. Uniform acceleration means acceleration is changing uniformly. So, so yes, if you want to calculate the area covered, and the distance covered by the body, then we can do it by finding the area of the shaded region. This shaded region. This will give the magnitude of displacement or the distance covered by the body. Is right? Yes, it is. Look at these two graphs. These two graphs are the this is velocity time graph for a body with moving with non-uniform acceleration. In the first figure, you can just see here the dot lines are not on a straight line. The dot lines are not on a straight line. Or not. Therefore, the motion is non-uniform. If the dots had been on a straight line, the motion would have been a straight line. In the second one, the graph is zigzag. That is also an example of non-uniform acceleration. Right? We have three equations of motion. The first one is V is equal to U plus AT. Second one is S is equal to UT plus half AT square. And third one is V square is equal to E square plus 2AS. So here U is the initial velocity, V is the final velocity, T is the time. S is the distance, or you can say displacement. So we have three equations in motion. So this is useful while calculating the distance covered by a body in a particular time or the velocity of a body. It's like